Hello everyone, welcome to my channel No More Average. In this video, we'll learn about the 2-sum, 3-sum, and 4-sum problems from LeetCode. So without wasting any time, let's get started. But before we move ahead, let me explain a simple real-life example. Imagine, a mom gives her son some money and asks him to buy 2 fruits. When he enters the fruit shop, the shopkeeper has already arranged the fruit packs. The packs are listed in increasing order of price to help the child. But still, the child needs to pick 2 fruits which fit in the budget. Now it will take him some time to choose the right pair. Here comes the solution. This problem is just like the 2-sum problem. Let's first understand the actual problem from LeetCode. We are given a sorted array and a target value. Our task is to find 2 numbers such that their sum equals the target, and return their 1-based indices. In coding, we normally start counting from 0. That's called 0-based index. But in this question, they ask us to return 1-based indices. That means we just add 1 to each index before returning it. Here comes an example. In the given array, the target is 60. We need 2 numbers that add up to 60. Look at 25 and 35. Their sum is equal to 60. This is easy, but for a large list, it's difficult to check every pair. So to solve this smartly, we use 2 pointers. In this approach, one pointer I starts from the left, and another pointer J starts from the right. We keep moving them. I goes to the right and J goes to the left, until they meet at the same index. But when both point to the same element, it means we're checking the same number twice, which is wrong. So to avoid this, we use a while loop with the condition such that left pointer should be less than right pointer. This makes sure both pointers never point to the same place. Now comes the main internal logic. If the sum is equal to the target, great. We return the positions of left and right. But if the sum is smaller than the target, it means we need a bigger number. So move the left pointer 1 step to the right. If the sum is bigger than the target, we need a smaller number. So move the right pointer 1 step to the left. And this way, we have found the pair that gives a sum equal to the target. If no pair is found, we simply return -1 for both values. That's the standard practice. And that's it. We solved the 2-sum problem in just 2 minutes. Now let's move to LeetCode 3-sum. We are given an integer array. We need to find all unique triplets that sum to 0. The result should not contain duplicates. Let's first understand this example using the 2-pointer approach. The first step is to sort the array. Next, we fix 1 pointer, I, starting from the beginning. Then we use 2 more pointers, left, which starts just after I, and right, which starts at the end. The left and right pointers move towards each other until they meet. Once they meet, we move I to the next position and apply the same 2-pointer approach again on the remaining array. By following this process, we find a total of 3 triplets that add up to 0. But as you can see, there is 1 duplicate triplets here. In the final result, duplicates are not allowed. Okay, now let's build our 3-sum solution with an easy example. First thing, always sort the array, because sorted array helps us apply the 2-pointer logic easily. Next, we create a for loop. We use I to fix the first number of our triplet. We go till length -2, because we need at least 3 numbers to make a triplet. Now, same as 2-sum, after fixing the first number, we apply 2-pointer logic to find the other 2 numbers. Left starts just after pointer I, right starts from end of array. We run a while loop until left is less than right. Inside, we calculate our 3-sum. If sum is 0, we found a triplet. If sum less than 0, we move left pointer. If sum greater than 0, we move right pointer. Now let's iterate our approach with example until we find our triplet. Processing I at index 0, left moves to right if sum is less, and right moves to left if sum is more. We keep checking sums. And that's how we found our first triplet, -4, 0, 4. But now, if we simply move left pointer, next element is again 0. If we don't skip, we'll get same triplet again. So, we add a small check, skip the next same element, but also make sure left and right don't cross each other. If both the condition meets, we simply increment our left pointer. And that's we found our next triplet. Again, after that, next element is same, so our check skips that. Good. Now, I moves to next element, but the next element is same as previous one, that is -4. If we don't skip, we'll get same triplets again. So, before loop continues, we add a check. If the current number is same as the previous one, we skip, but we only do this check when I is greater than 0, because when I equals 0, there's no previous element. If we try to access array at index -1, it gives index out of bound error. So we always check I should be greater than 0 first to stay safe. As we can see, we are doing same kind of calculation, and that can slow down compilation process. So we apply same skip logic. If next element is same as current, we skip that too. Again, by decrementing right pointer, making sure left and right don't cross them. Now, iterating through our rest array, we get results. And that's how we build 3-sum code. Okay, we already learned how to solve 3-sum step by step. Now, using the same idea, let's build 4-sum solution. Trust me, it's super simple once you understand 3-sum. We go to LeetCode 4-sum. We need to find all unique quadruplets where the sum is equal to the target. And again, no duplicates allowed. First, as always, we sort the array. We add a for loop to fix the first number with j. We stop at nums.length -3 because after fixing the first number, we still need 3 more numbers to form a quadruplet. And that's it. Once we fix the first number, we can simply apply our same 3-sum logic inside, only with a few small modifications. Here, I equals j plus 1 means we start looking for the second number, just next to the first number. After fixing 2 numbers, we apply the 2-pointer approach to find the other 2 numbers. We calculate the sum of all 4 numbers. If sum matches the target, we store the quadruplet like this. And to avoid duplication created by pointer j, we apply the same skip logic for j pointer. Before we finish our solution, we must check the constraints. As in 4-sum, array length can be 1 or more. But to find quadruplets, we need at least 4 numbers. To avoid this problem, we apply a simple logic. If the given array is null or size is less than 4, we directly return our result, which is initially null or empty. And that's it. We have solved 4-sum problem. Congratulations! Within just 10 minutes, you've understood how to solve 2-sum, 3-sum, and 4-sum step by step. For more such easy, animated, and beginner-friendly videos, don't forget to hit the like button. It keeps me motivated. And subscribe to the channel. It helps your learning too. Keep learning, and together, let's say, no more average.